Hello everyone, we are here to do our video walkthrough of practice quiz number 2 for learning target number 7, trigonometry. So let's start up at the top here, our golden standard. Solve for the indicated side or angle using trigonometry. The key for this one is you're gonna want to remember what? SOHCAHTOA. I would recommend writing that on the top just so that way it's less you have to keep in your head. So first step, let's identify our sides. We're looking for an angle on this first one. So we're looking for an angle. We have what two sides? The hypotenuse, and we have the adjacent side. It is next to our reference angle. It connects the reference angle and the right angle. So with adjacent hypotenuse, we're going to use cosine. And we don't know what our angle is, so cosine of theta equals adjacent 31 over hypotenuse 47. So in this case, let's go ahead and solve this. Start with your equation. So I have cosine of theta equals 31 over 47. Now, when I'm solving for an angle here, what do I need to do? I need to use inverse trigonometry. So I'm going to take the inverse cosine of both sides. When I do that, what happens? Inverse cosine and cosine cancel out, and I get theta equals the inverse cosine of adjacent 31 over hypotenuse 47. When I put that in my calculator, theta equals 48.73 degrees. So for each one of these, again, we're going to start with the same steps. All right, let's do number 2. I see a 57-degree reference angle right here and these two sides. Let's identify it. I see my hypotenuse down here. That's not included. X is across the triangle, so that must be opposite. The 12 connects the reference angle and the right angle, so it must be adjacent. Opposite and adjacent goes with TOA, tangent. So I know that tangent of 57 degrees must equal my opposite x over my adjacent 12. Okay, great. Next, how do we start solving this? I'm going to recommend you just rewrite it down here to give yourself space. First step, what are we going to do here? We want to undo our fraction to get x by itself. So let's multiply both sides by 12 over 1 times 12 over 1. When I do that, on this side of the equal sign, the left side, I get 12 times the tangent of 57 degrees. And that's going to equal what's left over. Well, I multiply by 12 to cancel out dividing by 12, so I'm left with just x. At this point, I put it into my calculator, 12 times the tangent of 57 degrees, and I should get 18.48 equals x. All right, last one. Again, same steps. Reference angle. Identify your sides. I see the 15s are crossing the reference angle, so that must be my opposite. X is the hypotenuse. Which ratio uses opposite and hypotenuse? OH goes with so I'm going to use sine. So the sine of 38 degrees equals opposite over hypotenuse. All right, let's go ahead and write it out. So the sine of 38 equals 15 divided by x. They all kind of work the same way. Undo the fraction. How? Multiply by the denominator, x over 1. When I do that, what happens? On the left side of the equation, I have x times the sine of 38 degrees, which means we multiply by x to undo dividing by x, which equals 15. This is different from the one before because x is not by itself. It's still multiplying sine of 38. How do I undo multiplying by sine of 38? Divide both sides by the sine of 38. Divide both sides by the sine of 38. Those cancel. Multiply by sine of 38 divided by sine of 38 works out to just be 1, so it cancels. I'm left with just x equals 15 divided by the sine of 38 degrees. When I put that in my calculator, I get x equals 24.36. That is the golden standard. All right, hopefully that was helpful. Let's now use those skills in some contexts. Nick is standing 50 feet away from a tree that is 30 feet tall. His eyes are 5 feet above the ground. What angle would he need to look up to see directly to the top of the tree? This is an example of what we call a context problem, an application problem, colloquially referred to as a word problem. First step, sketch a diagram. The picture is the whole problem. If you can draw the picture, the rest will solve itself just like you did up here. The hard part is drawing the picture. So let's draw this. We got Nick. So Nick's over here. And he's 50 feet away from a tree. Let's draw a tree here. It's a very narrow tree. And he's 50 feet away from it. Okay? And the tree is 30 feet tall. Now, Nick is looking up to the top of the tree. What angle would he need to look up to see directly to the top of the tree? Now, angle is our key that we're going to be using inverse trig here. That's our clue. We're going to be using inverse. So we're trying to figure out what angle would Nick need to look up at to see the top of the tree? Well, we always want to make a right triangle here. So now we see that. There's a right triangle. What do we know about this right triangle? We're trying to figure out what angle Nick would need to look up at. So that means that's theta. Now, in this specific triangle, what do we know? We know that this distance is still 50. That distance hasn't changed. His feet to the tree, his eyes to the tree. But what's the height on this side? 30 is the height of the tree from the ground to the top. But we just found out that Nick's eyes are 5 feet above the tree, 5 feet above the ground, excuse me. So this 30 needs to get cut into two pieces of 5. And what's left? 25. Because 5 plus 25 equals 30. So our new triangle we're actually working with, if we drew that separately, would look like this. It's a right triangle. We're solving for this angle theta, where this side is 50, this side is 25. Solve this just like it was the one you just did in the golden standard. Identify your sides. This side is opposite. This side right here, 50, connecting the reference angle to the right angle, is the adjacent. So opposite and adjacent means we want to use tangent. So we know the tangent of theta equals opposite over adjacent. In order to solve this, what do we need to do? We said it already, inverse. So we're going to take the inverse tangent of both sides. Those cancel out, so I'm left with just theta equals the inverse tangent of 25 over 50, which works out to be theta equals 26.57 degrees. So Nick would need to look up at 26.57 degrees from where he's standing to see directly to the top of the tree. And we can box that so it's clear. All right, there are standards 1 and 2 down. Let's move on to standard 3. Standard 7.3 is special right triangles. Now here, you have 2 patterns to remember. All right, I might write these down kind of maybe over here on the left. That way, again, it's just less in your brain. 2 triangles. First one, 45, 45, 90 triangle. This is the x. The 2 legs are the same. And the hypotenuse is the leg times the square root of 2. So there's one. The other one I might recommend writing down is the 30, 60, 90 triangle. Now in this one, the side opposite 30 is x. The side opposite 60 is x times the square root of 3. The hypotenuse is 2x, double the short leg. First step, look at the triangle, identify. Well, which pattern is it? 30, 60, so it's this pattern right here. What side am I given? I'm given the hypotenuse, so I know that this is the 2x side. Okay. So 2 times my triangle, my x number, equals 70. So my short leg right here, opposite the short leg right here, opposite 30, is half of 70. So this side must be 35 centimeters. If you look at this side right here, 35, is just like this side here. To go from the short leg to the hypotenuse, I double it. To go backwards, I halve it. 70, half of 70 is 35. Finally, to move to the long leg, opposite 60, I take my short leg, 35, and I multiply it times the square root of 3. Now, it might make sense when you're doing this. I'd recommend, I see another 30, 60, 90. Let's do that one. Instead of jumping patterns, let's do the same pattern. Here, I can see this is my x root 3 side. Opposite 30 is my x side. The hypotenuse is my 2x side. So 23 times the square root of 3. So what's my x number? What's multiplying the square root of 3? It's 23. So the short leg must just be 23, meaning the hypotenuse is 2 times the short leg, which is 46. All right, let's do the middle pattern, 45, 45, 90. These two angles are the same, which means these two sides are congruent. So if this leg is 11, this leg must also be 11. Lastly, my hypotenuse, I take my legs and I multiply them by the square root of 2. There we go. Those are our special right triangle patterns. All right. So our next problem down here, our final standard, standard 7.4. Our final standard, 7.4, is about non-right triangles. So we're trying to find the measure of angle A. Well, our key here is probably going to be in a non-right triangle. We want to look at using the law of sines. All right? Law of sines is going to be our go-to tool for this. Now, the law of sines is all about a side and its opposite angle. So we want to look for side angle pairs. I can see that 10 connects to 112. I can see that this side 7 connects to this side angle B. And angle A connects to this side down here, which I don't know yet. So I can't get to angle A because I don't know that side. But what can I figure out? Well, if I know, let's start with angle C here. I can see C is going to be 112 degrees and 10 inches. I know I'm going to solve for an angle eventually. So let's put our angles on top. Whatever we're solving for, put it on top. So the sine of 112 degrees over 10 equals. Now, what other should I use here? Well, I should just use whatever information I have. I know this side is 7. I don't know what angle B is, so I have to put the sine of angle B. All right, let's solve this. I want to solve it out for angle B. So first step, let's multiply both sides by 7. Let's undo the fraction, multiply both sides by 7 over 1. When we multiply fractions, we multiply straight across. So 7 times the sine of 112 degrees divided by 10, because 1 times 10 is 10. That's going to equal, the 7's cancel. 7 divided by 7 is 1, so we don't have to include it, equals the sine of B. Now, how do we undo this? How do we get to just B? Whenever you're solving for an angle, what do we need to use? We need to use inverse trig. So we're going to take the inverse sine of both sides. So what does that look like? That means we have the inverse sine of 7 times the sine of 112 degrees divided by 10 equals, those two cancel. The inverse sine undoes the sine to leave us with just angle B. All right, leaves us with just angle B. When you put this in your calculator, the inverse sine of this, you're going to find that angle B is about 40.47 degrees. So that is the measure, of angle B. So angle B right here is 40.47 degrees. Now, my whole goal here was to find the measure of angle A. Well, can I find the measure of angle A now? Absolutely I can. Why? Because 180 is going to equal angle B, 40.47, plus angle C, 112, plus the measure of angle A. They all add up to 180. So if we add that together, take it away, turns out measure of angle A equals 27.53 degrees. That's where we want to finish. All right, I hope this was helpful. Good luck on your LT7 quiz.